Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster series, and this episode is going to be very interesting because in this video we are going to fix all of the problems with our pathfinding and get it to work quite well. So to do this, what we are going to do is first of all look at some problems. The first thing is that you might notice is that sometimes our enemy actually fails to notice us. So if in here, if I turn on game mode, you can see that the enemy does not notice me, and if I shoot him, he does start to chase me, and you can see he gets stuck at the corner. So those are some problems that we need to fix. But firstly, let's see why the enemy is not noticing us. Well, the reason is that if I open up my thing.cpp, you can see that in here when we are checking whether we should whether we can see the player or not, what we basically do is we get our dot product, and after getting the dot product we do a raycast. Now we do check all things and we check if the thing that we hit was the player. However, this won't exactly work very well because we might not hit the player. We might direct a raycast with the thing itself. We could pass the current thing as a pointer, but then the player would be able to hide behind other things. Essentially, we only want the player to hide behind map elements and not hide behind things. So this method won't really work that well. So what we need to do is we need to do a raycast, but we need to only check the player. So we are going to actually just add that functionality into our raycast function as well. We are going to just take another thing pointer as an argument, which we'll call check, and by default it would be null. And what this will do is that if I go under raycast.cpp, I'm going to go up here. Then I'm going to just add this here, so I'm going to add a thing pointer here called check. And what we are going to do is if I go all the way down where we are doing this, if our thing is equal to ignore, we continue. But if we have got a thing that we need to check and our current thing is not equal to the thing that we are supposed to check, then we are also going to continue. So this will make sure that if we only check our player. So for the ignore thing, we'll just pass in null pointer because we are passing in a check, so the passing in ignore is kind of pointless. So the check value will be equal to our player, and what that will do is it will only check our player, and we just need to check if our hit dot thing is valid, because we don't actually need to check if it's equal to the player because it cannot be equal to anything but the player. So if I go ahead and run this, what you should be able to see is that now our enemy does detect us correctly. So yeah, you can see that's working. But of course the enemy currently struggles to go around the wall. That's because of we are just trying to linearly move from one grid cell center to the other grid cell center, which is not working very well. So we are going to actually change this just a little bit, but the solution that I've got up here is kind of hacky a little bit, but it's not that terrible, and it does get the job done. So what we do is we are going to currently, instead of moving from the center, or instead of moving to the center and making it kind of hug the wall or something, we are going to go ahead and get map cell. We are going to take our states, map, get the cell, and we are going to get the cell which is equal to our x value and our y value plus 1, basically the bottom one. And we are going to of course check the wall layers, and if we are actually there is a wall below the current cell, that because our algorithm generally generates paths along walls, so we only need to check one cell. You could for better control, you should probably check all of the cells below it according to the size of the thing, but checking one cell does get the job done for our purposes. We are going to get that, and if you've got something below us, then we are going to subtract 0.5 from our y value, so that we don't go to the center, instead we go to the top value. And otherwise we are going to just do the same thing. If there is something on the top, then we are going to add 0.5 so that we go to the bottom corner of the wall. And we are going to essentially do the same thing for the x-axis. The only difference of course is that now we are going to not check this on the y, but instead keep the y as default, and we are going to check this on the x, like that. And here we are also going to add it to the x. Now what you should be able to see is that our enemy is able to generate and follow the path quite correctly. As you can see, the enemy goes from the top and then it goes here. And actually that didn't work because we are adding to our y and x values, which is not what we want to do. We need to add it to our next vector that we are moving to. You can see that now if I go ahead and press this, the enemy is able to find the path correctly. You can see that the enemy still does slide a little bit around the edges. However, it's not really that noticeable, and it's not really that big of a problem to be honest, because it doesn't look that bad, and it does get the job done. We could try to make it a bit better by using some smoothing algorithms or something, but for our purposes this works, and we are not going to have like super large sized enemies anyways. And if you want to do that, you could look into some path smoothing algorithms or something, but well, we are going to pretty much wrap this up here. So anyways guys, this is going to be pretty much it for this video. I'll see you in the next one, and make sure to like and subscribe as well, and share this video with other people, and bye.